Okay everyone, let's go ahead and solve another question. So can I solve this by using the undetermined coefficients? Right, this is an exam. I give you this question. I'm asking, can you solve this by using undetermined coefficients? The answer is no, you cannot, because I have a 1 over 1 plus. So the polynomial, if this was here, 1 plus x squared times e to the x, you should be able to, okay? But now you have to use the variation of parameters, okay? Just to note myself, it will be easier. F of x will be e to the x by 1 plus x squared, okay? Alright, so I will do the same approach. Y will be equal to yc plus yp, where I have my yc to be y double prime minus 2y prime plus y is equal to 0. And so from here I will get the ancillary equation as m squared minus 2m plus 1 is equal to 0. And you kind of see that m minus 1 squared is equal to 0. And I get m1 comma 2 will be equal to 1. So I have a double root over here, okay? As I have a double root, my yc will look this way. c1 e to the x, because root is 1, plus c2x e to the x. So arbitrarily, again, it doesn't matter which one, but I'm going to call this y1. I will call this y2. So let's write it in here. My y1 will be equal to e to the x. My y2 will be equal to x times e to the x. Then I will go to the next step, which is to find my yp. Okay, yp. And the yp, as we established, it's going to be u1x times e to the x, which is y1, plus u2x times x e to the x, which is a y2. And the goal here is to find my u1 and u2 values. Alright? So u1 prime will be w1 by w, and u2 prime will be w2 by w. Let's start by the w. I usually start to get it out of the way because that typically is the harder because there's no 0. So I have myself y1 and y1 prime. y1 prime is e to the x, right? Y2 is x e to the x, and y2 prime is chain rule e to the x plus x e to the x, right? So if I multiply these, this can get messy. We'll find out e to the x times e to the x plus x e to the x minus e to the x times x e to the x. So you see that this term and this term is the same, right? So they cancel. Well, I mean multiply by this is the same, right? So you can cancel these and you get yourself, what is e to the x times e to the x? E to the 2x, right? Okay, so w is e to the 2x. Not too bad in my opinion. Let's go to w1, which will be, remember we were replacing 0 and f of x was e to the x by 1 plus x squared, and y2 is basically, I go here and copy this, x e to the x, e to the x plus x e to the x, and you can see it in here. I will get myself minus x e to the 2x by 1 plus x squared. Not very nice, but we'll work with it. How about w2? This time around I do the other way around. So this was e to the x, and this time I'll write 0 in here, e to the x by 1 plus x squared. If I go down over here, I will get myself e to the x times e to the x by 1 plus x squared. So if I rewrite this, I'm going to get e to the 2x by 1 plus x squared. Okay, not bad. Well, we'll find out. u1 prime, now we will understand whether it's not bad or not. It will be equal to w by w, w1 by w. So w1 was up here, x e to the 2x by 1 plus x squared. Obviously there's a minus sign, let's not forget that, divided by w was e to the 2x, remember that? So I cancel e to the 2x's and I got myself minus x by 1 plus x squared, which will be equal to du1 dx. Okay, just like the previous question that we solved, do you see that this is the natural logarithm of this? Because if you think about this, let's call this f of x, and the derivative of this is 2x, so obviously I need to multiply by 1/2. But at the end of the day, I get myself u1 is equal to 1/2 times ln of 1 plus x squared. So if you don't see this, what you may want to do is just call 1 plus x squared is equal and make the substitution, and you will see this. You're going to get this. What about u2? Well, let's find out. u2 prime will be equal to, this time around, w2 by w. And I have myself e to the 2x by 1 plus x squared, right? That was the w2. Let's double check that. Yep. Divided by w was e to the 2x, I'm sure. So this is cancelled. I get myself 1 over 1 plus x squared, which is equal to du2 dx. I discussed this in the previous segment. So this will be the arctangent, okay? Arctangent of x. Or if you want to write this, it's written as tg minus 1 of x, if you choose to, okay? So this, I don't. I write this, but, just showing. So this is going to be the arctangent. The derivative of arctangent is 1 by 1 plus x squared. Okay, this is something that you kind of need to know. But I want to, let's do a different color over here and illustrate something. As I said, arctangent is equal to tangent minus 1x, right? Just to illustrate, cotangent is 1 over tangent. So I'm not talking about this, just for everybody to be on the same page, okay? What is tangent of arctangent of theta? I have an angle, tangent of arctangent of theta will be theta, okay? And the cotangent of theta times tangent of theta, what will be this? Remember, this is sine by cosine. This is cosine by sine, so you can see 1, right? So I just want to give you this flavor over here, so we know what we're working with, okay? And all right, so that's fine. I will go ahead and write my yp then. Yp will be u1. u1 was minus 1/2 ln of 1 plus x squared. And my first root was e to the x. Plus, the second one will be the arctangent of x e to the x. So x e to the x was the y2. Okay. Now I will have to combine. So y will be equal to yc plus yp. So if I write this, I will get myself c1 e to the x plus c2x e to the x minus 1/2 ln of 1 plus x squared e to the x, right? Plus arctangent of x e to the x. So if you choose the one last step, you can take everything with the e to the x parentheses. So you get yourself c1 plus c2x minus 1/2 by ln of 1 plus x squared plus arctangent of x. So you can see this is going to do it. You should practice more just to be familiar, but this is kind of it for this particular approach that we have established. Have a good day. I'll catch up with you in the next segment.